right, so we're going to talk about elimination a little bit more. These are a little bit different. I skipped number 7 because it's the same as the last video, but these are still using elimination, but we may have to do a little bit more to get started. So if you look, your x's are lined up, your y's are lined up, and your coefficients are lined up. But the equal sign, the y in the first equation, is on the right side, and on the second equation it's on the left side. So we have to make sure those are lined up. So the first thing I'm going to do is take my first equation and I'm going to subtract 3y so that my x's and y's are on the same side of the equation for both of my equations. I'm not going to change anything with the second one right now. I'm just going to bring it down. And then when I look at it, I can see that these both have a -3. This one has a 1 and a 2. So I can eliminate my y's the easiest, but I'm going to have to subtract the bottom equation from the first one. So I'm going to subtract. Remember, if I subtract a negative, I'm going to add that and subtract the 16 there. All right, so x minus 2x is -x. And then -3 plus 3 eliminates. That's why we did what we did. And then 11 minus 16, which is -5. Divide by -1. X equals 5. All right, so take 5 and plug it into one of the equations. So I'm going to have 5 equals 3y plus 11. And then subtract 11. And 3y equals -6. Divide by 3, y equals -2. All right, so we have our x and our y. So that's our ordered pair, x and y. And then I'm going to plug it in to check it. All right, always plug it in, make sure that it works. All right, 5. Does 5 equal 3 times -2? 3 times -2 is -6, plus 11 does equal 5. All right, the second equation, 2 times 5 is 10, minus 3 times -2. -3 times -2 is plus 6. Does 10 plus 6 equal 16? It does, so that checks out. All right, number 9, it has a y and an x and a y and our coefficients. So the first thing we're going to have to do is, again, rewrite one of the equations to set it up to where our x's and y's line up. All right, so the first thing I'm going to do is equation 1, I'm going to subtract my x to the other side because I need my x's and y's on the same side. So if I do that, I'm going to put that in front of my 4y just so that I can line up my x's and y's. And commutative property says the order doesn't matter as long as you don't change the sign. So I'm going to subtract 2x, and I have positive 4y, and if I subtract 2x, then it goes to the other side. I don't have one here, so that equals 8. And then I'm going to bring down my 5x minus 4y, and that equals 20. All right, now I can look at this and say I have a 4 and a -4. So now those automatically eliminate once they're lined up and on the same side of the equation. So I can simply add these equations together and find x. So -2x plus 5x is 3x. This one's going to eliminate. And then -8 plus 20 is positive 12. Divide by 3. X equals 4. Then I'm going to take my x and I'm going to plug it back into one of these equations. So let's plug it in my first equation. So 4y equals 2x minus 8. And I'm going to replace the x with the 4. So I have 4y equals 2 times 4 is 8 minus 8. And 4y equals 0. Divide by 4, y equals 0. All right, so we have our x and our y. So our ordered pair is 4, 0. Go ahead and check it just to make sure. Okay, this says 4 times 0, because that's our y, is 0. Does that equal 2 times 4, which is 8? 8 minus 8 is 0, so that works. And then in the second one, it says 5 times 4, which is 20. 20 minus 4 times 0, which is 0. Does 20 equal 20? It does. So this is our solution. All right, number 10. When we look at number 10, we have our x's and y's lined up and our coefficients, and the equal sign is also lined up. So we can go ahead and call this equation 1 and equation 2. And since I have 3 and 3 and -4 and -4, this is probably going to be one of those unique situations. But let's see what happens. We need one of these to eliminate. So I'm going to change the sign. So I'm going to subtract the second equation from the first one. So if I subtract, I got to subtract all the way across, which means I change each sign. Now when I do that, 3x minus 3x, that cancels. And I have -4y plus 4y, that also cancels. So on the left side of the equal sign, I have nothing there, so that's 0. And then on the other side, I have -10 plus 13, so that equals 3. All right, we know that 0 does not equal 3. 0 can never equal 3, so that means there's no solution. And you may also see the null set to represent no solution. That means these have parallel, these lines are probably parallel. They will have the same slope and different y-intercepts. So if you were to graph those lines, you could see that they had no points of intersection, which would be the solution. So number 10 is no solution or null set. All right, for number 11, again, our x's and y's are not lined up. So the first thing we need to do, I'm going to move over here to the left since I have some extra space over here. Since my x's and y's are on the same side on the top equation, I'm going to leave it alone this time. So all I did was rewrite the first equation. And the second equation, I need to subtract or move my x to the other side by subtracting it. So I'm going to have -2x. When I subtract it, I have -y still, and that is equal to +10. All right, now I need to look at my equation. I've got 2x minus 2x. I can add these together and that will eliminate. So that's going to eliminate. And then I have y minus y. That one also eliminates. So once again, we're going to have 0 equals. And then this one says -10 plus 10. Well, that equals 0 as well. This is a true statement. So when you get a number equal to itself, that's a true statement, and that means your answer is all real numbers. We also see the infinity sign used sometimes for this. So there's examples of elimination, and I hope this helps.